So hello, I'm Pratham Ritna and I have done this project of multi-class fish image classification. It was a part of the internship that I am doing. In this project, I've trained the convolutional neural network, that is CNN, from scratch, giving me a strong understanding of how custom architecture behaves with our dataset. I've provided a GitHub link over here, you can go and check it. The problem statement was the objective of this project is to build a deep learning model that can classify images of fishes into multiple species categories. The dataset contains labeled images of different fish species. The goal to train models that can accurately identify the correct species of the given image. I imported the libraries, loaded the dataset, that's it first two dataset row and column. So total the training sample is 6,225, total validation sample is 1,092, and total test sample is 3,187. Duplicate values are zero. Missing values no directly found. Data handling code. So here we move to the data visualization. In this, the chart number one is class distribution in training set. The bar chart clearly visualizes how many images belong to each fish species in a training dataset. It helps check for the image imbalance, which is a crucial in classification task. Moving to next, chart number two, which is sample image from each class. I personally wrote this code to remove the few sample images from the different classes. It helps to understand visual diversity of the dataset and verify the image are clean, relevant, and correctly categorized. The third is image count per class in train validation and test sales. The fourth one is training versus validation accuracy, which goes when the epoch and its accuracy goes high, epoch goes high. The next chart is of training versus validation loss. The chart helps to monitor how well the model minimizes error during training. Shows the model is converging, overfitting, or underfitting. The next chart is confidence matrix on a test set. It shows how many times each class was predicted correctly or incorrectly. The next is classification matrix per class. The next chart is class distribution in test set. Moving to the final chart, it is prediction confidence and distribution. It analyzes how confident the model is when predicting whether it is often unsure or blindly overconfident. The next is hypothesis testing. Based on the chart experiment, I defined three hypotheses. The first one is the model performance significance based on class A than on class B. The second is the average prediction confidence for correctly classified images higher than the misclassified images. Third is there is no significant difference in the class-wise image distribution between train and test set. The first I use Z-test. The second I use sample t-test. The third one is chi-square test. This handling mismatch handling outliers. Next is handling outliers. For image classification dataset, traditional numerical outlier prediction does not directly apply. Category encoding, textual data preprocessing, lowercase a, removing punctuation, removing URL, and etc. etc. Now, I'd like to move on to the ML model 1. In this, we got the evaluation matrix of accuracy of 9.2, precision 9.0.91, recall of 0.90, and reference score of 0.91. So before training, the accuracy was 85%, and after training, training accuracy was 90. The validation score 82%, and validation accuracy is 88%. Going to the ML model 2, the accuracy I got is 0.151, which is plus and test loss is 5.1768. I use random search CV in this. Going on to the ML model 3, I have used random search model in this also because it's fast and conceptual computationally efficient compared to grid search CV. Here the accuracy was 88% in the baseline of 91%. I deployed it using Streamlight model and done. In conclusion, the project demonstrated the practical ability of deep learning in fisheries domain with potential for deployment in real-time fish species identified system using mobile or web app. Thank you. That's it for the project.